Okay, in this video, we'll see how to differentiate the inverse hyperbolic cosine function. Of course, you can see the answer on the shirt right here, but of course, we'll do it legitimately right here. I'll show you guys two ways to do it. First way is that we can actually just differentiate, just like last time, we actually have an expression for the inverse cosh function, and that expression is in terms of the natural log, and that's natural log of x plus square root of x squared minus 1. Therefore, we can just differentiate this, and we can go ahead and do that. The derivative of ln is just going to be 1 over whatever you have inside. That goes down right here. So we have x plus square root of x squared minus 1. And then you have to remember the chain rule. You have to multiply by the derivative of the inside. And since it has two terms, be sure you open the parentheses for both terms. The derivative of x is 1. And then we are going to add the derivative of a square root something is first you do 1 over 2 square root of the inside, stays the same. So you have the x squared minus 1. And then the chain rule again, multiply by the derivative of x squared minus 1. And the derivative of that is 2x. So you multiply by 2x right here. And this is pretty much it, but we can actually simplify this expression more. And to do so is first we can just cancel out the 2. And you see, this is a fraction pretty much, and then right here we can just combine the fraction. Let me multiply this by square root of x squared minus 1 on the top and also on the bottom. So we see right here we still have the 1 over x plus square root of x squared minus 1 times. This and that now have the same denominator, which is square root of x squared minus 1. On the top, you see you have 1 times the square root of x squared minus 1, and then plus x. And of course, the order of addition doesn't matter. You can write down x first if you like. I think I will. Let's just put this down right here, x. And then plus that square root of x squared minus 1. And check this out. This is technically has a parentheses, likewise this right here. And they are exactly the same, so you can cancel them out. In the end, the answer is just 1 over square root of x squared minus 1. And can you guys tell me if I got this right or wrong? Yes, I know. Thank you. Now, let's do this another way right here. Well, how can we do this though? That's the inverse function. I don't know it too well, so let's try to come up with the original function. So what we are going to do is I will say that y equals the inverse hyperbolic cosine function. When we have this, I can take the original cosh on both sides. So I can look at this and say the original cosh of y that's equal to just x. And by looking at this, I can differentiate this with respect to x. And because the y is no longer isolated, this is technically implicit differentiation. Well, you have to remember the derivative of the original cosh function. And that's actually positive sinh. So this right here, we first get sinh, and the input is still y. And now, because y is a function of x, we have to multiply by dy dx. And on the right-hand side, the derivative of x is just 1. So that's what we have. And yeah, that's pretty much it. And then of course, if you want to get dy dx by itself, we can. And that's equal to 1 over sinh of y. And here's a small issue. One is that, you see, this is not the same as that. But the main issue is, this right here is in terms of y. Our original expression, especially if you look back here, I want an expression for this derivative to be in terms of x. So we have to do some work right here. And this is the work that we are going to do. We have sinh of y, and here's a connection between sinh and cosh, the original versions. So let me write down the note for you guys. Remember that we actually have this identity when we have cosh square of some input, and let me just put on t for the input. This minus sinh square t. When the inputs are the same, and when you are subtracting, cosh goes first like this. This right here gives you 1. And right here we have sinh to the first power. So I want to isolate this. Let me move this to the other side, and let me move the 1 to here. So we see cosh square of t minus 1, that's equal to, this is going to give us positive sinh square of t. And I will just have to take the positive square root on both sides so that this and that will cancel. And I just care about the positive because if you look at the graph of the inverse hyperbolic cosine, you will see that it's an increasing function. Therefore, the derivative has to be always positive. So you just want the positive square root. So you see that sinh of t, this is equal to square root of cosh square of t and then minus 1. And here we have sinh of y. Therefore, I'm going to come back here and change this to, we have the 1 over. This is going to give us square root of cosh square of the same input. So you have to put down y right here. And then minus 1, like this. Well, where's x? X is cosh of y. And right here we have cosh square y. So this is actually just x squared. So finally we see that this right here is equal to 1 over square root. And once again, cosh of y is x. So this right here is just x squared. And then you have the minus 1. And with that, we are done.